In this video, I will show how to set up an integral to find the volume of the solid of revolution using the shell method. And let's start by sketching the region. And the region is between the graphs of y equals x squared, which is the upright standard parabola, and y squared equals x, which is the sideways parabola, or the piece that we are graphing is the same as the function y equals x, square root of x. And we're going to be rotating this region around the horizontal line y equals 1, and the solid of revolution will look something like this. Now, if we're going to use the shell method, we have to figure out which, with respect to which variable we're going to integrate. And that depends on what the shells are defined by. So if we were to break this solid into shells, the shells clearly have to be horizontal like this. And that means that we will be integrating with respect to y variable. And the limits of integration will be from 0 to 1, because the lowest value of y that defines a shell is 0, and the largest value of y that defines a shell is 1. Now we're going to pick some arbitrary value y, and we're going to find the expression for a volume over shell at y level. So let's pick this y value. That means the width of the shell will be dy, which is part of the integral notation here. And let's take this shell out and let's cut it open. When we cut it open, we're going to have the following rectangular box of width dy, of height dy. Width will be, we can call it w, and width will be this, if we trace it back to the original diagram, width will be this distance over here, which is the distance between the graphs of these two equations. Now, since we're integrating with respect to y, both of these equations must be written in terms of x equals some function of y. So the piece of the sideways parabola is already written in such way. It is x equals y squared, and the piece of the upright parabola can be, and should be rewritten as x equals square root of y. So now, using these expressions, we can express w as the difference between square root of y and y squared. Now, the length of this box will be equivalent to the circumference of this base of the shell, and for that we have to know the radius. The radius will be the distance from the axis of revolution to y. So the radius is 1 minus y, and therefore the circumference will be 2 pi r, but r is 1 minus y. So L is given by this expression. So the volume of each shell, using this notation, will be expressed as 2 pi r times width, which is square root of y minus y squared, times height, which is dy, and it is already part of this integral notation. So this is the integral that finds the volume of the solid of revolution.